Well, good morning, everybody. Today, we're going to finish up about our sphere Earth versus flat series. Today, I'm going to talk about differences in sunrise and day length. If you remember our series, the first video I talked about circumference and tilt. I took 19 cities from timeanddate.com and calculated circumference, tilt, and latitude using solar high noon. So check that out. For part 2, I did distances and rotation. So I have proof for the rotation of the Earth. And then part 3 that we did last week was more about distance calculation. And then I also did surface areas. And we had a big surprise at the end. I think you all will agree it was just mind-blowing. This is the map from where I got the 19 cities. And you can see I tried to keep sort of a straight line here, a straight line here, and a straight line here. I called these North and South America. These points I called Europe and Africa, and these points Asia and Australia. Here is some data that I had from the North and South America points. You can see I had alert, which was at 83 degrees, way far north, all the way to Puerto Williams, Chile, which was at 55 degrees south. And the first set of data here was for sunrise at the different equinox and solstices. The second set of data over here was the length of the day at the equinox and solstices. And then I really didn't use the rest of this data. So what I was curious about was if you take latitude versus the sunrise times, and then latitude again with the length of days, what we would see on a graph. So here are my two graphs for North and South America, and you can see kind of clearly here that the spring equinox and the fall equinox are virtually the same. They follow each other all the way from the furthest south to the furthest north. And then summer is this purple line, or I'm sorry, winter is the purple line. Summer is this turquoise line. And you can see that they're kind of opposite each other. So at the very south, for summer, the length of the sunrise is later in the day. And for the north latitudes, it's earlier in the day. For winter, it's just the opposite. In the south, the sunrise is earlier in the day and sunset is later, or I'm sorry, for the south latitudes and for the north latitudes, the sunrise is later in the day. And then day length is much more obvious here. For the spring and fall equinox, you can see clearly they both lie right on top of each other, and day length during those equinoxes is almost exactly 12 hours clear across the latitude. So, as we know, the sun is crossing the equator, and so day lengths are equal all during those equinoxes. The winter solstice for the southern hemisphere, day length is much greater. If I had more south points, you'd see it would be up close to 24. And then in the north latitudes, the day length gets very short. And in fact, down here by Puerto Williams, day length is almost zero. So even in South America, you have a 24-hour night. Then for the summer solstice, day length is very short in the southern hemisphere, and it gets very long in the northern hemisphere, up by Alert, Canada. You can see we have almost 24-hour long days. Okay, so this is for North and South America. For the Europe and Africa, we get the same thing, almost identical. You still see that for spring and summer equinoxes, that the sunrise is, between 6 and 7 a.m. all the way across latitudes. The summer sunrise is later in the southern hemisphere and much earlier in the northern hemisphere as we get closer to the North Pole. The winter, again, is just opposite of the summer. So the winter, we start with very early sunrises, and then up near the pole, we have much later sunrise. Same thing with day lengths. Again, the fall and the spring day lengths lie right exactly on top of each other and are 12 hours across the latitudes. Winter, again, has shorter days in the southern hemisphere, or I should say longer days, 15 hours to the shortest possible, down near the South Pole. So Cape Town, Africa, South Africa, has almost 24-hour nights. For day length in the summer solstice, it's exactly the opposite. Shorter day lengths in the southern hemisphere, all the way up to 24-hour days near the North Pole. For Asia and Australia, we have exactly the same thing. You can see the equinox, or the equinoxes follow each other almost identically. Summer and winter solstice are opposite each other, exactly like the other two. And then looking at length of day, clearly summer or spring and fall lie right on top of each other and are exactly 12 hours in the spring and fall. In the summer and winter, they're exactly opposite each other. So you can see at this latitude that's close to the equator, in winter the day length is 0. In summer the day length is 24. So they are opposite each other. And this point down here, which happens to be on Antarctica, we have 24-hour days in the winter solstice, and 24-hour night during the summer solstice. So they follow each other exactly everywhere on the Earth. And each latitude kind of follows each other, as you can see on this chart. So what exactly does this tell us? Spring and fall are intermediary and have the same sunrise and day length for every point on the Earth. Spring and fall, it's always 12 hours, day and night for every point. Summer and winter are exact opposites of each other. 24-hour days and 24-hour nights can be seen both for far north latitudes and far south latitudes. These things aren't, you just can't have these on the flat Earth. It just doesn't work with a close sun that's like a spotlight. So let me show you one note. On the most widely accepted flat Earth map, the AE projection, the sun is a small spotlight illuminating a circle on the Earth. This circle would have to have a brighter, hot center which cools toward the edges. This is just not the way of reality and sunrise, sunset, and day length. It's just not the way it works. Here's the flat Earth map, and I've kind of shown where my 3 lines of cities are. And you can see, like day length in spring equinox is going to be the same all the way from North Pole or close to the North Pole down to South Africa. So if you imagine a circle, a spotlight sun coming up, there's just no way to get it to hit all of those points at the same time, because the circle is an arc. So I think it's pretty clear that sunrise times and the day lengths are obviously showing that the Earth has to be a globe. There has to be a sphere. There's no other way that it can work. Here are some of the websites that I used again, just to make sure I credit everybody. And here are some of the websites that, or some of the YouTube channels that are inspiring and show some good science and physics. I encourage you to watch these guys. And that's all I have for today, so a little shorter than usual. Have a good day.